This lesson is to describe the central tendency of a data set, create and interpret box and whisker plots. A measure of central tendency describes the center of a set of data. Measures of central tendency include the mean, median, and mode. The mean is the average of the data values, or the sum of the values in the set divided by the number of values in the set. The median is the middle value of when the values are in numerical order, or the mean of the two middle numbers if there is an even number of values. The mode is a value or values that occur most often. A data set may have one mode or more than one mode. If no values occur more often than another, we say the data set has no mode. The range of a set of data is the difference between the least and greatest values in the set. The range describes the spread of the data. The weights in pounds of 6 members of a basketball team are 161, 156, 150, 156, 150, and 163. Find the mean, median, mode, and range of the data set. Write the data in numerical order, and then add all the values and divide by the number of values. 150 plus 150 plus 156 plus 156 plus 161 plus 163 divided by 6 total basketball players is 936 divided by 6, which is 156 for the mean. Since there are an even number of values, find the mean of the two middle values for the median. So if you count toward the middle, they're an even number. We have 156 and 156. 156 plus 156 divided by 2 would be 156. So the median is 156. For the mode, 150 and 156 both occur more often than any other value. For the range, 163, the greatest value, minus 150, the least value, equals 13. The weights in pounds of 5 cats are 12, 14, 12, 16, and 16. Find the mean, median, mode, and range of the data set. This one's for you to try on your own, and then you can check back for your answer. You're going to write the data set in numerical order, 12, 12, 14, 16, 16. Then to find the mean, you're going to add together all the numbers and divide by how many cats there are, which is 5. So we get 70 divided by 5, which is 14 for the mean. For the median, since there's an odd number, there is a middle number, and it is 14. So the median is 14. For the mode, 12 and 16 both occur twice. For the range, 16 minus 12, the greatest number minus the least number, is 4. A value that is very different from the other values in a data set is called an outlier. In the data set below, one value is much greater than the other values. Identify the outlier in the data set 16, 23, 21, 18, 75, 21, and determine how the outlier affects the mean, median, mode, and range of the data. You're going to write the data in numerical order, 16, 18, 21, 21, 23, 75. Look for a value much greater or less than the rest. The outlier in this data set is 75. With the outlier, the mean, adding together the numbers and dividing by how many there are, is 29. The median is 21. And the mode, 21 occurs twice, so that is the mode. For the range, 75 minus 16, it equals 59. Without the outlier included in the data set, the mean is 19.8. The median is still 21. The mode, 21 occurs twice. The range now is only 7. The outlier is 75. The outlier increases the mean by 9.2 and increases the range by 52. It has no effect on the median or the mode. Identify the outlier in the data set 21, 24, 3, 27, 30, 24, and determine how the outlier affects the mean, median, mode, and range of the data. This one's for you to try on your own, and then you can check back for your answer. So you're going to write the data in numerical order, 3, 21, 24, 24, 27, 30, and you're going to look for a value much greater or less than the rest. The outlier is 3. With the outlier, the mean is 21.5. The median is 24, the mode is 24, and the range is 27. Without the outlier, the mean is 25.2, the median is 24, the mode is 24, the range is 9. The outlier is 3. The outlier decreases the mean by 3.7 and increases the range by 18. It has no effect on the median and the mode. As you can see in example 2, an outlier can strongly affect the mean of a data set, having little or no impact on the median and mode. Therefore, the mean may not be the best measure to describe a data set that contains an outlier. In such cases, the median or mode may better describe the center of the data. Rico scored 74, 73, 80, 75, 67, and 54 on 6 history tests. Use the mean, median, and mode of his scores to answer each question. The mean is 70.7, the median 73.5, and there is no mode. A. Which measure best describes Rico's scores? The median, 73.5. The outlier 54 lowers the mean, and there is no mode. B. Which measure should Rico use to describe his test scores to his parents? Explain. The median, 73.5. The median is greater than the mean, and there is no mode. Josh scored 75, 75, 81, 84, and 85 on 5 tests. Use the mean, median, and mode of his scores to answer each question. This one's for you to try on your own, and then you can check back for your answer. The mean is 80, the median 81, and the mode 75. A. Which measure describes the score Josh received most often? Josh has 2 scores of 75, which is the mode. B. Which measure best describes Josh's scores? Explain. The median, 81. The median is greater than either the mean or the mode. Measures of central tendency describe how data cluster around one value. Another way to describe a data set is by its spread, how the data values are spread out from the center. Quartiles divide a data set into 4 equal parts. Each quartile contains 1/4 of the values in the set. The first quartile is the median of the lower half of the data set. The second quartile is the median of the data set. And the third quartile is the median of the upper half of the data set. The first quartile is sometimes called the lower quartile, and the third quartile is sometimes called the upper quartile. The interquartile range, IQR, of a data set is the difference between the third and first quartiles. It represents the range of the middle half of the data. You can see data listed here. First finding the median in the middle, 5, that's quartile 2. Then taking the first half of the lower half of the data set and finding the median of that, the first quartile is equal to 3. On the right-hand side, the third quartile, or the upper part of the data, the median is 7. So you can see that the total range, 9 minus 1, would be 8, but the inner quartile range, IQR, would be 7 minus 3, the median to the median, which is 4. A box and whisker plot can be used to show how the values in a data set are distributed. You need 5 values to make a box and whisker plot: the minimum or least value, the first quartile, median, the third quartile, and the maximum or greatest value. The number of runs scored on a softball team in 19 games is given. Use the data to make a box and whisker plot. 3, 8, 10, 12, 4, 9, 13, 20, 12, 15, 10, 5, 11, 5, 10, 6, 7, 6, and 11. Step 1, order the data from least to greatest. So we have 3, 4, 5, 5, 6, 6, 7, 8, 9, 10, 10, 10, 11, 11, 12, 12, 13, 15, and 20. Step 2, identify the 5 needed values. 3 is the minimum. For quartile 1, the median is 6. Quartile 2 is the median of the entire set of data, which is 10. Quartile 3 is the median of the upper set, or third quartile, which is 12. And 20 is the maximum. Step 3, draw a number line and plot a point above each of the 5 needed values. Draw a box through the first and third quartiles and a vertical line through the median. Draw the lines from the box to the minimum and maximum. You can see we have a dot for the minimum, the first quartile, the median, the third quartile, and the maximum. The edges of the box are the first and third quartiles, the vertical line is through the median, and then we have horizontal lines drawn to the minimum and maximum. Half of the scores are between 6 and 12 runs per game. 1/4 of the scores are between 3 and 6. The greatest score earned by this team was 20. Use the data set to make a box and whisker plot. 13, 14, 18, 13, 12, 17, 15, 12, 13, 19, 11, 14, 14, 18, 22, and 23. This is for you to try on your own, and then you can check back for your answer. Step 1, order the data from least to greatest. 11, 12, 12, 13, 13, 13, 14, 14, 14, 15, 17, 18, 18, 19, 22, 23. Step 2, identify the 5 needed values. Minimum is 11, first quartile, 13, median or second quartile, 14, third quartile, 18, maximum, 23. Step 3, you're going to draw your box and whisker plot. A dot for the minimum, first quartile, median, third quartile, maximum. The box goes from the first to the third quartile, the vertical line goes through the median, and then horizontal lines go to the minimum and maximum points. Half of the data are between 13 and 18. 1/4 of the data are between 11 and 13. The greatest value is 23. The box and whisker plots show the number of mugs sold per student in 2 different grades, 8th grade and 7th grade. About how much greater was the median number of mugs sold by the 8th grade than the median number of mugs sold by the 7th grade? So you can look at your graph, and it's about 6. B, which data set has a greater maximum? Explain. The data set for the 8th grade, the point representing the maximum, is farther to the right for the 8th grade than for the 7th grade. Use the box and whisker plots to answer each question. This is for you to try on your own, and then you can check back for your answer. A, which data set has a smaller range? Explain. The data set for the year 2000. The distance between the points for the least and greatest values is less for 2000 than for 2007. This is B for you to try on your own, and then you can check back for your answer. B, about how much more was the median ticket sales for the top 25 movies in 2007 than in 2000? About 40 million.